Okay, so we're here in my Lancer Evolution 844 X-Ray, and we are going to do gear cons. All right, so first things first, when you go to the gear location screen and you enter all of your landing gear data, you can simply leave these boxes unchecked, and you will get the default spring and damping and tire pressure for the airplane. Okay, X-Plane comes up with the default based on the size and the weight of the airplane, and the size of the tires, and the location of the tires. Tire pressure, that matters because that affects your hydroplane speed. Spring constant, that matters because that affects how much the gear will be depressed as the airplane sits on it. Damping constants, that matters because that's how much the oscillation will get damped out as the airplane tends to hit and then rebound. And so all three of these critical things, spring constant, damping constant, and tire pressure for hydroplaning, which is simulated in X-Plane, are all automatically determined. And I have found that the default guesses that I come up with are fine for flying the airplane. But sometimes you want to go to a higher level of detail. Like, for example, the spring steel struts on a Cessna definitely have a different feel than the compressed oleos on, say, a Piper Arrow, as I found. So you can check these boxes and start entering stuff manually. Let's go through it here. We're going to start with our tire pressure for strut stiffness. And you'll note this also applies to hydroplaning speed. So what you can do, once you've entered the correct tire size in the gear location tab, which you can do on your own, enter the tire pressure for each tire here as well. And what's so interesting about this is, once you've entered the tire pressure and the tire size, PlaneMaker here, it can kind of figure out what the force on that tire needs to be, and it can automatically find what the load must be on the strut. And you'll see here that strut load at max weight. You'll notice there's no buttons here to enter this data. That's because it's automatically estimated based on the tire pressure and tire size. And look, if I increase the tire pressure, look here, there's more load on the strut. And if I decrease the tire pressure, there's less load on the strut. And the same thing is the case with tire size, which we can enter here in tab 1. So X-Plane figures out, or estimates, I'll say estimates, the load on each strut based on the tire size and the tire pressure. Now, what you enter is, what is the deflection? How much does the gear get deflected? And I've just entered 0.3. Well, 0.37 is what was automatically chosen. Oh, an interesting thing is you can change these values to any sort of crazy things that get all like messed up and make no sense. Don't worry, if you uncheck these and then check them again, as soon as you uncheck them, X-Plane's set to a nice, decent default. So if you ever get the data all screwed up and you don't know what to do, you can always just uncheck these. X-Plane will put them back to default, recheck them, you'll see the default values again. But at any rate, based on the tire pressure and size, we've got the load, and then you enter the deflection. And if you enter the deflection of each of these struts at the maximum weight of the airplane, well, that derives a spring constant. Shows how much landing gear must be deflected for each pound. But here's the thing, landing gear on airplanes has two different spring or a changing spring constant. The more the landing gear deflects, the greater the spring constant, and the less it deflects, the less the spring constant. I don't know why that is. Maybe someone can tell me in the YouTube comments, but the constant varies. So what we do, because spring constants vary with the deflection, which means they're not actually constant, we have a manual entry for the partial deflection case. This is the low load. So to kind of wrap this up, the tire size coupled with the tire pressure indicate the tire load. The tire load is automatically loaded into the strut load at max weight. You enter the deflection at max weight. That gives the gross weight spring constant. Then, to have the gear be softer for partial deflections, maybe to help with smooth landings, you can enter lower weights and deflections here to get a softer gear constant. And then finally, you can enter the damping constant as well. The damping constant is simply how much oscillations are damped out. All right, now I'm gonna get technical just because, hey, you clicked on the video link, might as well. The spring constant, that is how much the landing gear resists getting compressed. If this is like the top of the landing gear, or this is the bottom of the landing gear, the spring constant is how much the landing gear resists getting compressed in meters, say. The damping constant is how much it resists getting compressed in meters per second. This is like how much it resists the motion. And if you imagine an airplane with both a positive damping constant and spring constant, on landing as the tire is compressed up, it's resisting with a force both from the spring and the damper. But as the gear rebounds, as the airplane starts to bounce up again, it only has the spring constant force. The damping constant is actually resisting the gear coming down. So in other words, the gear resists with spring and damping here, but resists with spring minus damping on the rebound. So the rebound force is always much lower than the compression force. And since the rebound force is lower than the compression force, what does that mean? You see it? Compress and then slow rebound, which means the airplane can slam onto the runway and not bounce back up very much. That is the beauty of the damping constant. And there's very little damping constant in the main gear struts of, say, a Cessna 172 because they're just that spring steel. There's no real damping to speak of. And that's why you'll see Cessnas kind of going boing, 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 bouncing down the runway over and over. If the pilot doesn't have control of the airplane, it's because there's not very much damping in those struts. So for a Cessna, you might enter lower damping constants here. And if you enter low or no damping at all, you'll see the airplane gets kind of harder to land because it wants to bounce if you don't land smoothly enough. That's a fun experiment. You should definitely try it. So to wrap up, just in case I was going too fast here, enter your landing gear radii and locations. Everything should be fine. If you want to do it manually, that's great. Enter your tire pressures. Your airplane will hydroplane at the right speed. X-Men will automatically estimate the weight on each wheel. You can enter the deflections at gross weight. That is the gross weight spring constant. You can enter strut and deflection at lower weight if you want to get the lower spring constant at the lower weight, or the beginning parts of the deflections for those smooth landings. You can enter the damping constant manually, and the greater the damping constant, the more the thing just goes smush like Play-Doh. And the lower the damping constant, the more it's just like a pogo stick and bounces back. And I encourage you to try some different damping constants, radically different damping constants, and then try and fly the airplane and see what it's like to land. It will be a lot of fun. This is like a perfect use of PlaneMaker and X-Plane.